Imagine a world where you're instantly connected with your technology as if you had telekinesis. Whether you're somebody who's differently abled or fully abled, you'd be able to interact, create, and innovate simply by thinking. Or what if your technology could feel what you feel and be able to react in a smart way, be able to help you overcome the challenges of life, and be able to optimize who you are as an individual?
Dr. Ramses Alcaide, the CEO and founder of Nurbal,
Been working on brain-computer interfaces, taking brain activity and interpreting it to control a computer.
If I could sum up the Nurbal experience in one word, it would be
fantastic, mind-blowing,
excellent,
a taste of the future,
exciting,
motivating, future,
transcendent.
Nurbal, the mind unlocked.
Wow, that was incredible. Might have to use your video team in the future. This is great. Hey everybody, how's it going? My name is Dr. Ramses Alcaide. I'm the CEO of Nurbal. Today we got a fun panel. We're going to be passing around some brain-computer interfaces. I'm going to try to get everybody as involved as possible as well too. So a brain-computer interface is basically a system that records your brain activity. We all got one of those, and sends it to a computer. And then at the same time too, you can take a computer and send commands to the brain. Now what this means is actually incredibly powerful. There's a ton of applications for it. So for example, cognitive biomarkers in wellness. Right now, for example, it takes us 10 years to understand whether a person has Alzheimer's or Parkinson's. Right? 10 years of people having that disease before we're able to actually quantify it and do something about it. Imagine you had some sort of system that could record your brain activity. We could track that over time, be able to create new discoveries and new innovations, or even provide therapy earlier. Or even something as simple as wellness. One of the systems that I'll be showing you today, and we actually have a demo in the back, is used to track your focus. And we have actually used that technology with a lot of different groups, and what we found is that if we can track an individual's focus, we can understand when they're starting to burn out. Burnout consistently leads to depression. Right? So what if we could understand when you're starting to burn out and tell you to take a break? Something as simple as that could have a tremendous amount of value. And on top of that, we're even now licensing this technology to the DoD for pilots. Because when we can figure out when they're tired, we can prevent accidents from happening. And about 30% of the accidents that happen is because of fatigue. Or let's talk about customized experiences. Let's say you're trying to work. You're focusing on the work that you're doing. What if we could play music that could help you get into a deeper focus? What if we could play something when you're feeling down to make you feel a little bit better? How can we customize the experiences around us? Well, we can do that organically using brain activity. Or even silent control. How cool would it be to be able to send a text message using your AirPods? Right? This is the future that we're building at Nurbal, and really something that we're excited about. But there's one key problem, and that is that right now this is how brain-computer interfaces look like. Most importantly is this one here to the right, which is, I guess it would be your left, these laboratory-grade systems. So this is what the state-of-art looks like. It's this giant cap that you wear on top of your head. It has these metal prongs, or sometimes these like wet prongs, so there's gel that goes through your hair and makes contact with your scalp. And the reason people use these is because they have very high quality data. You need this type of data to be able to do anything functional with it. There's also a lot of these consumer grade systems. And the main issue with those is that their signal quality is so poor that you really can't do anything with it. So what we did is we did a survey over 1,000 people. And we went out there and we figured out, why aren't brain-computers interfaces scaling? They have such a tremendous impact that they could do to the world. It's the last organ we're not tracking, which is our brain. You have wearables for everything but your brain. And they have such a huge impact to what we can do. And yet, they haven't scaled. And so what we did through this 1,000 user interview is we found 5 key areas that have prevented brain-computer interfaces from scaling. The first one is function. A lot of the times when you use a brain-computer interface, it works very poorly. And I have a video in just a few slides where I'll be showing you what the state-of-the-art looks like and then what we've been able to accomplish at our company. The second one is cost. In order to get one of these high-quality brain-computer interfaces, they cost $20,000. Right? That's not going to be something that your average individual is going to buy. The next thing is societal fit. Not only do people think it's weird to have brain-computer interfaces on your head recording your brain activity, your brains are kind of sacred to us, right? So we don't want somebody monitoring our attention, right? We also don't want something that looks weird on top of our head that signifies that we have the system on top of us. And then on top of that is comfort. We're going to be passing around a brain-computer interface pretty soon. My partner here, Walter, from the company, is going to be helping us out. Go ahead, Walter, just stand up for a second. Yeah, you can give him a round of applause. Sure, go for it. So he has two brain-computer interfaces with him. One of them is this large VR headset that we did with HTC. And in the back, you'll see these prong metal sensors, right? This is what's considered state-of-the-art right now. And then the other brain-computer interface he's going to pass around is going to be a pair of headphones. It's one of our newest systems. And they have these silver bands, and that's what collects your brain activity. And what's really powerful is it took us a long time, but we took what was that VR system, and now we can essentially do very similar things with a pair of headphones and earbuds. And so what the headphones let you do is they look like a normal product. They're not weird, right? We even have another prototype that looks like a pair of AirPods, right? So now they become everyday devices. And then the last thing is the user experience. We still don't know how to build good UIs, UXs, good experiences for people with brain-computer interface because it's so new. And so this is an area that our team has been working very diligently over the last 8 years to really perfect and create what we call a brain-computer interface that works like an Apple product. And so what we did is we came to these lessons, which is like, what are the key things that we need to actually bring a brain-computer interface into an everyday situation? And they're not loading, but essentially that's why I use text. It's down there, which is we need a high-performance, everyday look and feel device that's low cost, but provides a valuable use case. And so this is where Nurbal comes in. So we started at the University of Washington, and actually University of Michigan. Sorry, I did my undergrad in Washington. But go blue if there's any Michigan people here. And essentially what it is, it's an AI. It's an AI that takes brain activity and increases the sensitivity that we can record and understand the brain from. And essentially what you see in this top graph here is what raw brain data looks like. Now, you don't really have to understand what the graph is showing, but essentially it's messy. It's a ton of noise. You can't really tell what's going on. And then what we do is we're able to apply our AI, and it's able to smooth all this noisy information down so that you can easily tell what are blue areas, what are red areas. Once again, you don't need, I don't need you to have a neuroscience degree. Just smooth, not smooth is, that's the main takeaway of this slide here. And what that means from a practical perspective is that we can start to create brain-computer interfaces that really feel like the future. And so I'll show you this video here. This is actually from about 4 years ago, but it really captures the difference of what the state of the art is right now versus what we're doing, which is significantly ahead of what's in most laboratories.
Brain-computer interface. And here the person is just focusing their conscious want on a letter, and it's able to type it out. Now just notice, he's trying to type the letter I right now, how long it takes for it to work. And this has been the key issue with brain-computer interfaces. The accuracy and the speed is just so slow that we haven't been able to do too much that's been useful with it. I mean, did you guys just notice he just typed the I? That took forever. And this is what Nurbal is working on. We are the first company to shatter the performance barrier of brain-computer interfaces, to allow a brain-computer interface that can actually be used in real applications, in real consumer goods. But instead of just talking to you about it, I want to show you guys our technology for yourselves. So let's switch to the demo feed. There we go. So right now, Adam is wearing a 7-electrode dry EEG system, so that means it doesn't use any gel. Normally, you would have to use gel. It's recording his brain activity from the parietal and occipital regions. Just to let you know, I have a PhD in neuroscience. So a lot of this work has come from that. And what we're going to do is we're actually going to have Adam here walk through an environment and interact with objects with his mind.
Wake up. This is not a test. You need to escape from here. Remember, your new powers allow you to perform actions using your mind. When an object flashes, that means you have control over it.
So, this is a game demo that we've been showing to people.
You need to find a way through this door. Look around for clues.
And really what Adam has the ability to do is grab objects just by wanting it and throwing them just by wanting it. And this is all done in real time. Previously, this was something not possible to be done with electroencephalography, or EEG, which is the brain sensors that he's actually recording. And all of this is happening in real time. And some of you have even been able to try it during our demo. But here you can see him typing into a keypad. And while these are very simple movements, you can see
So what you saw there is you saw somebody first trying to type the letter I, and you saw how slow that was, right? And now we're actually able to do full VR demos. And I wish you could try it here today, but the computer got damaged on the way here. But if you're ever in Boston, come by. You can try the demo yourself. And that was us, back in like 2015. So we've really evolved the technology since then. That was actually 2018-ish timeframe. But the big thing that happened at the University of Michigan in 2011 as part of my PhD work is really unlocking the signal processing capability. And then what we've been doing time after time is we started out with these gel electrode headsets in 2011. That's the picture that's supposed to be there. And then we've been working to slowly bring this tech into smaller and smaller devices. So we've gone to this dry electrode system that you can see in 2015, the VR system in 2018, and now we're at the point where we can essentially integrate this technology into headphones, earbuds, AR glasses, and even helmets that people can wear. And so our company essentially licenses this technology to different hearable and wearable technologies, companies, to bring this tech into everyday devices. And now I want to talk to you about why this is valuable and how this can become valuable for every individual as well too. And Walter, feel free to pass around the headset as well too. So there's three kind of core applications that we see this technology be really useful. One is conscious control. This is the kind of stuff that most people think about when they think about brain-computer interface. Typing with your mind, clicking on objects, moving things around. Another one is enhancing technologies, and this was one that I think is really cool. How many of you have an Amazon Alexa or any of those voice assistants in your house? Raise your hand high. Yeah, there you go. A lot of you, right? How often does it get it wrong? Somebody just yell out. All the time? Okay. Everybody agree with that? Sometimes? All right, she's got a better experience. Cool. Well, what if you could use the brain to make it better, right? To reduce the errors that are out there. And then there's even effective computing. What if we can understand an individual and what they're feeling and help create environments for them that can help them, maximize their productivity or feel happier just simply by assisting them. So I'm going to be going through each three of these applications and showing you how we're working to actually bring technology like these into everyday products. Now, you already saw one of our previous systems, the VR system for clicking. But now I'm going to talk to you about the future of control. I'll ask the audience a quick question, which is, we've had voice technology for a while now. It's really powerful, it's really easy to use, but why do we still not use it more than the touchscreens that we have to message people? Privacy, okay. Latency? User experience? What do you mean by user experience?
We're just acquainted to using our thumbs for using our phone.
Okay, it feels more natural to use our thumbs versus phone. Misunderstandings, errors. So as part of that 1,000-person study, we asked this question too. And we came to two conclusions that were the core drivers. One is privacy. If you're on a bus with a whole bunch of people sending a text message to your loved one, you don't want people to hear at you. Or what if you have an embarrassing question, right? You don't want people to hear you say it, right? The second thing is there's so much noise around us that you're going to get false positives. Like imagine using this in a food court. It's just not going to work, right? So what if we had a technology that could instead use our brain as the sound source? So we're not interfering with all the sound that's around us. It's just us. Well, this next video clip that I'll show you is one of our brain-computer interfaces that actually uses the headphones that we have in the back area. And what it can do is when you think of a word, and you're going to see this girl mouthing it so that you know what she's essentially trying to do. But when you think of it, we're able to pick that up, process it, and then use it for very simple commands. But over time, we're going to be able to build on top of that dictionary set of commands that we have to create longer word forms, text messages, etc. And so she's going to be controlling Spotify. She's going to say the words play, pause, and forward in order to skip the music and essentially control it. But no microphones are being used.
Suzanne takes you down to her place near the river. You can.
So you can see there that she's just wearing a pair of headphones, but now this is her form of texting, of using it. Imagine if your next computer isn't your phone. Imagine if your next computer is your AirPods. Imagine if your next computer is your AR glasses. And what is going to be the mouse and keyboard for those devices? Brain-computer interfaces. You're not going to want to carry extra controllers with you. You're going to want to be able to put one device that has both your control and all the features that you need to really enable an everyday use form. So enhancing technologies. Remember we were talking about Alexa, right? Imagine you're trying to get a Toyota for your kid and it thinks you're trying to buy a car, right? It's going to be a very expensive mistake if you don't catch that early, right? Well, your brain actually has this incredible capacity of understanding when something is wrong. Now, I want you all to pay extra attention to this next part because I want you to pay attention to how you feel. All right, so I'm going to say a sentence and it's going to be a little bit weird. And there's going to be a moment where you're going to internalize, what did he just say? Yesterday I tested Diane's broccoli of the issue. Did that feel weird to listen to? That's actually your brain creating a response. And it's something that we understand already in neuroscience. It's this thing called the N400. It's a change that happens 400 milliseconds after you hear that error that happens in that sentence. So imagine we could understand that error in that translation that you just told Alexa, and instead of Alexa saying, oh, you trying to interrupt it, it just said, wait a minute, I think I got it wrong. It could be this, right? And we're able to tell the difference between semantic errors and also syntactic errors. Feel this one. The hearty meal was devouring the kids, right? Doesn't that feel funny? Doesn't that feel weird? Well, that's something called the P600. It's a brain response that happens when something feels wrong due to a syntactic error. And so your brain has so many of these really cool biomarkers that we can use to enhance technologies that already exist and make everything feel more seamless and really help break the next barrier of even voice technology or other systems that are out there. And the last one I'll cover is effective computing. One of the biggest nightmares that I have with AR is the fact that, one, we're already getting a ton of notifications, right? Imagine having an AR system and everything is popping up and it's just going to be a bad experience. But what if instead we could tell when you want to focus on a task? And as you start focusing on that task, your headphones, your earbuds, they turn off your notifications automatically. They turn on noise cancellation on your headphones. So you create this environment where you can focus and get into deep work. They can even turn on a light on your headphone to tell others, do not disturb. Right now I'm focusing. So we have a demo in the back over there where we actually have a light tower connected to a pair of headphones. And what we can use that for is to actually track your focus and be able to do commands and controls with it. And so in this case, we're showing it off in a gameplay perspective where we have a professional esports coach here, and he's going to be controlling this light bar. And the more red it becomes, the more focused this individual is on the task, and then my co-founder is going to distract him, and you'll see that the light bar will go down, and then he'll get back onto the task and it'll go up.
Hey Cass, what are you gonna have for breakfast tomorrow?
Oh god, we have a catering company now. Actually, I ordered food for a while for our team, and in the mornings it'd be awful because there's no.
Are you losing focus right now?
I'll let you get back to focus though.
And so we're actually using this technology right now with this esports team to help them with training and with practice and to be able to provide feedback to the players. There's even this one implementation that we have where the keyboard turns red whenever they become distracted. Or if they haven't picked up, for example, a notification of their teammate, they haven't recognized it, we can flash the keyboard green. And then they know that there's a chat message that came in that they missed. But then that way it doesn't make a situation where they already see the information and then it just becomes annoying to try to respond to it. And so these are the kinds of things that we can build. And this last slide here also shows another application of the future. Here, an individual is wearing a pair of AR glasses with brain-computer interface sensors built into it. What I think is really cool is, once again, your brain recognizes so much. So here I'm showing you a brain response called the error potential. Whenever your brain sees an error, it produces a different type of brainwave compared to when you see something that is correct. So correct is a solid line and error is that dash line. And so we can use that, for example, let's say that this person's going through a tutorial and there's a mistake that happens. That he accidentally hurts himself or something breaks. Well, we can then notify, for example, a manager, hey, something is wrong here, go send some help. Right? So imagine an area where we can use these error potentials to really help individuals and save lives. And then there's applications in cognitive analytics. Imagine we could make better content. Imagine we could create jump scares for people when they're playing games that actually tie to when they're the most connected to the game, so that they become the most impactful. So there's a lot of things that we can do with effective computing for brain-computer interfaces. And right now, our company is fully focused on bringing this technology, focused on cognitive performance and also very simple controls in headphones. And this is not like something that's 20 years away. The first products are actually coming to market in Q4 of this year. So we've already signed one OEM to deliver 3 of their flagship devices with our tech. And we have 3 other OEMs that are integrating their technology with ours. And so between 2023 and 2024, you're going to be able to go to the store and buy your favorite pair of headphones with an integrated brain-computer interface to both help you track your cognitive health, but also be your next computer. And as this technology evolves, these cognitive performance markers become biomarkers to helping solve disease. Imagine understanding anxiety or identifying individuals with ADHD earlier so that they can get the treatment that they need. Basic controls become texting with your mind. And then these biomarkers turn into closed-loop therapies, customized analysis for an individual, or even controlling the Internet of Everything. And the form factors start to change as well, too, from headphones to earbuds to VR and AR. Brain-computer interfaces are going to be an everyday part of our lives, and they're going to provide a significant amount of value to the world. And so that leaves me at one of my close to final slides, but I want to show you the future that we're trying to build at Nurbal. And I think this encapsulates the entire future. You're not going to see any headsets or anything on here, because I think what matters is that we should make technology that is seamless and for humans. And that's really core to our mission at Nurbal.
What if the future we want, the technology that will remake our world, is already inside of each of us? What if the future is our brain, unlocked? We see a future where patients with chronic illnesses find new independence, where we can monitor brain health data in real time and share it with the doctor, transforming data into customized treatments in the process. We're building a future where our brain can tell us when it's tired, so we'll always know when we need to take a break, to boost productivity and happiness. We see a future where music listens to us, to the way we're feeling at a neurological level, with custom playlists curated for our current mood. We're building a future where we even communicate differently, by thinking, not typing, turning thoughts into inputs, where we can tell our loved ones we're safe, just by thinking it. At Nurbal, we're harnessing the power of the human brain to build the future we see. Not smaller screens and thinner bezels, not more technology, more human technology. We believe the future is a place where technology works for us while receding into the background. At Nurbal, we're not waiting for the future. We're building it into the devices we use every day. Nurbal. The mind unlocked.
And like I said, this future isn't that far away. The future where you can wear an AR device that you can monitor and help individuals prevent accidents, that we can help doctors have more hands-free experiences as they're working with patients in difficult situations, to be able to walk and talk and send a text message just simply by thinking about it. That's not that far away. We're building this technology now. It's going to be available soon. And it's a deep pleasure to share it with all of you. And we have some demos in the back as well, too. We love to talk to people. We love to share. So please feel free to reach out to either Walter or me if you have any questions. But thank you so much for your time. And I think that they gave me like 5 minutes for Q&A, too. So if you have any questions, now's the time.
Execute on keyword function.
It's a great question. So the question was, in the past, we had a lot more head coverage with our sensors. Now we're just picking data around the ear or in the ear. How do we get the same type of inputs from it? And the thing is, it took 8 years to do, but essentially we have 8 years, close to 4,000 individuals worth of data from these larger headsets down to these headphones. And yes, there is a signal loss that happens, right? But what we can do is we can use machine learning to back propagate those signals theoretically. And because the brain is so conductive, we can pick up much fainter versions of the other signals and then enhance them with the AI that we have. There's actually a whole white paper and a Nature article on it that covers it, but essentially we've been able to retain about 98% of the original signal. Yeah, so the question is, there's obviously privacy about you not sharing, your text messages that you're thinking about outward, but there's also privacy about protecting an individual's rights. And that's actually a really core part of our company. And we actually just published a paper in Springer Scientific about the neuroethics of brain-computer interfaces. It's a core part of what we do. Our perspective is that it should be a tool for empowerment. And I'll give you an example. We got approached by a nicotine company recently, and they wanted us to show, like, hey, we want to show that our nicotine is less addictive than another one, right? We said no, right? So part of it is that we choose who we partner with. The other one is we choose how the technology gets used. So a big company that makes software for offices, I'm not going to name any names, came up to us and they wanted to say, hey, we want this technology to monitor our employees to make sure that they're working, all right? And we said, no, this is what we can do if you're interested. It's not about monitoring your employee, it's about empowering them. What if they knew they need to take a break, right? What if they knew that they're getting fatigued? What if they knew when they focus the best, whether it's the morning or the evening? Right? And so what we did is we just completed a study with the Mayo Clinic, and individuals who used our system compared to taking breaks randomly or using a Pomodoro method, we saw that there was a 20% decrease in end-of-day stress and a 70% increase in happiness, end-of-day happiness, because they're not ending their days burnt out and tired. And then that leads to long-term depression. So our belief is if we empower people with the information of their mind, they will make better decisions. They can choose to do that. It's not about trying to monitor them. It's about trying to give them the tools to succeed. Probably have time for one more question. What is the impact of your body on this equipment? On your body, yes. So I mean, there's RF signals, right? Bluetooth, right? But thankfully, EEG is essentially puts like something called a Faraday cage around your head. A Faraday cage essentially prevents electrical signals from getting in, because we need it to be as clean as possible so that the brain signals don't get interfered with all the other signals that are around us. So, it's considered a low risk, no risk device, so we don't foresee any issues from that perspective. Yeah. Awesome. Thank you all. It's been a pleasure.